Need a special shape to show how starstruck your character is? Or crazy? Or whatever this is? In this video, I'll show you how to take the code we used to make circles in the last video, and with a few simple modifications, create stars, spirals, and whatever this is. In fact, the circle is a great jumping off place to creating a wide variety of shapes, so let's get started. As usual, we'll start in a 2D animation scene, split the view into a text editor, and create a new text file. This time we'll paste in our circle code we used in the last video. You can download that code from the link in the description if you need to. Perhaps the easiest modification to make is to change the number of points on our circle. This allows you to create a lot of different shapes. For example, if we only create 3 points in our circle, we get a triangle. Likewise, for our purposes, a square is nothing more than a 4-sided circle. By simply changing the number of points, we can create not only triangles and squares, but pentagons, hexagons, septagons, octagons, whatever. Need an icosagon? No problem. Another simple way to create interesting shapes is to vary the radius of the circle, but only on every other point. This allows you to create star and sun-like objects very easily. To do this, we'll revisit a trick we used in the first video on drawing lines. First, let's duplicate our ellipse function and repurpose it as a star function. Then we'll add a new parameter called offset. This will control the radius of the inner part of our star. A default value of 0.75 should work for now. In the main part of our function, we'll add 2 new variables, one for each of our x and z radii, that will store the radius values originally passed into the function. Next, in the section of our code where we're looping through the points, we'll add an if statement driven by a modulus operator. The modulus operator yields the remainder when one number is divided by another. In this case, we're dividing the point number by 2. If the remainder is 0, then we have an even number, otherwise it's an odd number. By using this in conjunction with an if statement, we will only affect every other point in the circle. Inside the if statement, if it's an even number, we'll multiply the radius times the offset value. Otherwise, we'll use the original radius value passed into the function. As you can see, this generates a star or sun-like pattern. If we set the offset to a value greater than 1, we can make the even-numbered points larger than the default radius too. This method works no matter how many points we have in our circle. Although, as you can see, if you have an odd number of points, you might end up with an asymmetrical distribution of spikes. But hey, if that's your thing, I won't judge. By decreasing the number of points in our circle to 10 and noodling the offset value, we can achieve a nearly perfect 5-pointed star worthy of any American flag. Another modification you could try is to change the modulus value to larger numbers. This will cause the radius change to happen less frequently and can generate some interesting shapes too. Between adjusting the number of points, the amount of offset, and the modulus amount, you can create a lot of interesting things. Another simple modification will allow us to make spirals. First, let's duplicate our circle function again and rename it spiral, and add an offset parameter as before. The spiral is really just a circle whose radius continuously either decreases or increases as the circle is drawn. To mimic this in our code, all we need to do is have our radius values change as we're looping through and drawing the points. We do that by modifying the points so that each time through, the radius gets multiplied times the offset. Every time we go to position the next point, the radius gets a little smaller. The straight line we were getting here is because we were previously closing our circle by setting the use cyclic attribute on the stroke. Since we don't really need that here, we'll set it to false. These changes work for creating this simple swooping spiral, but you'll notice that it only makes one revolution around the center. To make more turns, we need to revisit our code and make a few more changes. First, we'll add a new parameter to our function called turns. We'll use this to control how many revolutions we make as we draw the stroke. Since we'll be making more turns around the center, we'll need more points to work with. So in our call to the addPoints method, we'll multiply the number of points times the number of turns. This way the turns and the number of points on the stroke always stay in sync. Next, we'll adjust our step value so that we're multiplying 2π times the number of turns. To understand what we're doing here, we can revisit our trigonometry lesson from the last video. In that lesson, we learned that our step value is an angle expressed in radians, which are some fraction of pi, and then when it is set to 2 pi, we make a full circle. So by feeding 2 pi into our sine and cosine functions, we're telling it to do one complete revolution around the circle. What I didn't mention in the last video is that the sine and cosine functions are cyclical functions, which means that if you feed it values higher than 2 pi, it just repeats the cycle. For example, if 2 pi is one turn around the circle, 4 pi gives you 2 turns around the circle, 6 pi gives you 3 turns around the circle, and so on. With our new modifications to our code, we can take advantage of the cyclical nature of our trigonometry functions. By multiplying the number of turns we want times 2 pi, we can indicate how many times around we want to go. As you can tell, the more turns you add, the lower the number of spans becomes, until it becomes too square to really be called a spiral anymore. But this is an easy fix. If it's too low res, just increase the number of points until you get a smooth spiral again. The basic concept of modifying the points as you create the shape can be used in countless ways to create interesting variations in your shape. For example, let's go back to our circle and use our modulus trick again. This time, let's modify the point's pressure attribute, which controls the line thickness at that point, and we'll be making the line thicker on every other point. Let's decrease the number of points again so that we can see the effect better. We can also adjust things like the strength attribute, which controls the opacity of the stroke at that point. Applying the same effect to our star and spiral shapes and drawing them all at once can give us an interesting spiderweb effect. As you can see, once you know how to make a circle, you can make a wide variety of shapes with minimal changes. From here, the sky's the limit. As an example, I've written an add-on for Blender called Crop Circles that allows you to interactively create circular grease pencil patterns. And it was all done by riffing on the basic circle. I'll include a link in the description if you want to download it. Be sure to open up the code and check out what kind of modifications I'm doing to the circles to create these patterns. Maybe it'll give you some ideas for things you can try in your own code. Thanks for watching.